Okay, good morning, children. Now, today's topic is work done in isothermal expansion. We have to derive a relation for work done, okay, in isothermal process. In isothermal process, you know very well that the temperature will remain constant. So, in this case, we will assume that the temperature will remain constant. So, for that, consider n mole of ideal gas contained in a cylinder having conducting wall and provided with frictionless and movable piston. Here you can see this is a cylinder with movable piston and the wall is conducting so that there may be the exchange of heat to make the temperature constant. So gas is filled inside it. Due to the pressure, this gas will expand, this gas will move the piston upward by the displacement of dx. Okay. Now what will happen? There will be a small work done performed by the gas during the displacement of piston from this point to this point. So what will be the work done? Work done is equal to dW is equal to P into A into dx, and that is equal to P into dV, because area multiplied by the displacement give the change in volume and P is the pressure. Okay. So we are going to find total work done, and total work done will be from first state P1 V1 to P2 V2. Now the initial state is P1 V1, means pressure is P1 and volume is V1, and the final state is P2 and the volume will be at final state V2. So what will be the total work done? If we integrate this from V1 to V2, then we will get the total work done in this isothermal process. So WISO is equal to integration of dW, and that is equal to integration from V1 to V2 PdV. Okay. Now, because we are considering here an ideal gas having n moles, so we can write this ideal gas equation PV is equal to nRT. Okay. So PV is equal to nRT. So what will be the value of P? P is equal to nRT upon V. Now put the value of P in this equation, PdV. So by putting the value, we will get nRT upon V dV. But we know that n will be constant, R is the gas constant, and temperature is also constant because it is isothermal process. So nRT will be come outside from the integration, and the remaining term will be 1 upon V dV will be inside it. Now, what is the integration of 1 upon V dV? That is natural log of the V, and nRT will be in the left side. So, integrating natural log V from V1 to V2. What will be the result? WISO is equal to nRT natural log of V2 minus natural log of V1 by putting these two values, upper limit and lower limit. So this will be the WISO is equal to nRT natural log V2 minus natural log V1. Now we know the property of logarithm, that log A minus log B is equal to log A upon B. By the same property, you will get nRT is equal to nRT multiplied by natural log V2 V1. Okay, this is natural log, but I need log with the base 10. So what will we have to multiply? We have to multiply 2.303. So WISO is equal to 2.303 nRT log with the base 10 V2 upon V1. Now also we know that for isothermal process, the equation is V2 upon V1 is equal to P1 upon P2. Therefore, we can replace this V2 by V1 from P1 by P2. So, this equation can also be written as WISO is equal to 2.303 nRT log with the base 10 P1 upon P2. So, this is the work done during expansion in isothermal process. So I hope you could understand this derivation very easily.
Yes, sir.
Yes.